Oh, good afternoon, science folk. Good afternoon. Absurdity fans, I'm going to leave you out of this one. We are back to Mr. Neil deGrasse Tyson, Mr. Brian Greene, Mr. Brian Cox, Mr. Joe Rogan, and Mr. Terence Howard. I will hashtag, because I have a few questions about the speed of light, and I see you guys mixing it up, asking the questions, digging. I'm giving some digging stuff right here, right? Because I have got some valid questions. So the way I've structured these questions, all right, got only just 3 very basic questions, okay? I'm gonna keep this nice and light. What I have done, I've got 3 pictures. 1 with the naked eye, 2 average size telescope, 3 powerful telescope. What we have is a room in a house, and in that room, looking out of the window, are 3 people. 1, 2, 3. They are all looking at that sun. The person with the iPhone and with the naked eye, much like me when I go outside in the garden, right? And the image that phone is slinging onto the monitor, onto one of the monitors in the room, is that one there. Just that, basically, okay? Tiny. Then we have the second image. The second person is using just an average size telescope, like this one, okay? And he's, say, the middle person here, looking at the sun, okay? That is the picture that is getting sent to the monitor. Number 2, okay? And then we finally have number 3. So this is a monster sun because it's a monster telescope. It's actually iron. This thing is a monster, okay? Maximum zoom, zoom. Right, and this telescope, it's so powerful that it's giving us one of those like Soho pictures. You know, the solar observatory pictures that we get. It's zoomed in. That's all he can see in the eyepiece, in the lens, right? That is all he can see. So he zoomed right in. Feels like he can touch the sun, the filaments and the magnetic, and right. And that will be number 3, monitor number 3 in this house, right? 3 people looking at the sun, naked eye, medium telescope, monster telescope. And then underneath, this is just like a site map, right, of what is happening overall. So what we've got is, it's all very basic stuff, okay? I always worry about overloading. We've got the sun, got Mercury, Venus, just for show, just for a bit of depth. And then we've got the Earth and the Moon. And we know it's the Moon because that's Daisy the cow, okay? Now, 150 million kilometers from there to there. 150 million kilometers is the distance. The diameter of the sun is 1,390,000 kilometers. So we're going to divide the distance by the sun's diameter, and we get the number 107.9. Obviously going to call it 108 to keep things easy. So there are 108 suns in between the sun and Earth. Don't bother counting, there isn't 108 there. It's probably about 40 or 50, I don't know. Right? 150, 108 sun diameters in between Earth and the sun. Now, this question is, all of the questions are to do with the speed of light. As we know, rumour has it that it takes, rumour has it, right? It takes 8 minutes and 20 seconds, doesn't it? For the light to reach Earth. 8 minutes and 20 seconds, right? It takes 8 minutes and 20 seconds Because at the speed of light, which is 299,792 kilometers per second, it takes the sun 4.6 seconds to radiate its light the distance of its diameter. All right? This has got nothing to do with what is happening inside the sun. And I wish people would stop trying to get that involved. I am talking from here, one sun diameter, it's probably about there, right? It's taking 4.6 seconds. 4.6 seconds. Right? Now, I think it's an absurdity. I think it's ridiculously slow, because nothing in the universe that we know of radiates light that slowly. And I say that because of everything we know, right? We might as well just quickly throw the bulb in, because it's a gimme, right? If the sun were this bulb, it lights Earth and the moon up before I let go of the button, okay? Bang, it's everywhere. I can see it bouncing off the TV. I know it's a bulb, the sun's not to scale. But let's say that we did have the sun to scale, right? It does not matter how big, how small the sun is. We are looking at one diameter every 4.6 seconds. If it's that big, it's that big a diameter. If it's that small, it's that diameter. As long as you're doing 4.6 seconds for each diameter, you are keeping things in proportion to scale. The sun goes 1, 2, 3, 4.6. That is how long it would take this, if it were the sun, to radiate its light to there. Now, it's highly illogical. It doesn't really matter what anyone says. It's highly illogical, especially when we look at a bulb, especially when we look at lasers, at main beams on vehicles, everything, right? It's not per diameter like that. Why is something that is so big and so powerful, pound for pound, radiating its light slower than any other light source known to man, right? This is the bottom line. Just because it's massive kind of doesn't cut the cheese, does it? It is a monster. So why is it radiating its light like this? This is why these questions are coming up, right? So that is where we're at. I will come back with the first question, right? I'm going to post this reel, and I will try to keep the questions, they are very, very easy to understand. And for science folk, it should be a fairly simple answer. So I thank you for your time. Mr. Tyson, Mr. Green, Mr. Cox, Mr. Rogan, and Mr. Howard. Thank you for your time if you pick up the phone.